Let's have a look at the preparation for the mathematics paper 2 for the grade 10 for the November examination. Okay, so here with me, I have just 10 questions that I would like us to really go over. And then if time allows, I'll try to explain just a few aspects and add in here and there what needs to be done. And then, yeah, we shall see. Okay, so just like the paper 2 topics, we have statistics in this case. And the first type of statistics that we look at is the univariate type of data, where we look at just one variable. Okay. We have an example whereby we have the heights of 18 grade 8 learners that were recorded in centimeters as shown below. So we need to use the data to answer the questions that follow. So for this univariate, we need to know how to at least work with the basics of statistics, like determining the measures of central tendency, how to group the data, how to organize it, and so on and so forth. So the first question here is asking us to represent the data in a stem and leaf. So stem and leaf is just typical of grade 10. Okay. So in this case, we can have a stem, and then this side we shall have the leaf or the leaves. Okay. So if we have, let's say, whether we have 2-digit numbers or 3-digit numbers, the last digit should represent the leaf. Then whatever is left must be the stem. So for our case, we have 3-digit numbers. So if for 3 digits, so the last one is the leaf. And then when I look at the stems, which means my smallest stem is going to be a 12. Okay, so I have a 12. I can have, no, it's not a 12, it's actually 11. Okay, it's 11. Yeah, 11. Then we can have a 12. We can have a 13. We can have a 14. And then we can go as far as having even a 15. Then from there, I need to arrange this. So for 11, I see that the smallest leaf is going to be a 0. So I'll put my 0 there so that 11 and 0 represents 110. Is there any other number with 11? No. Let's go to 12. So I have this as a 12. I have this as a 12. And I have this as a 12. So I have 3 12s. Eh? But then out of those 3, 5 is the smallest leaf. So I'll write the 5. And then I have the 8. Then I have the 9. Then I'll move on to the 13. I have this as a 13, a 13. There's a 13. There's also a 13 there. So the smallest of the 13s will be the 0. And then after this, we have a 1. Then I have a 3. And then I have a 9. All right, then for the 14s, I have this. I have that. I have that. Is that all? All right. So the smallest is a 2. Then I have a 3. Then I have a 7. And then for the 15s, I have this one. I have that. I have that. Basically, so 151, 152, 153. Then we can have a stem of 16. So with 16, I have this basically. So which means it's going to be a 2, a 2, and a 5. So how many numbers are they? There are 18. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17. So something is short. There's a number that is shorting. Okay. Okay, I think we have 2 129s. So it means there's a 9 there, and that makes it 18 numbers. Okay, so perfect. Then now we need to find the median. Okay, so median, we know that that's basically the middle number. Ne? So with the middle number, since they are 18, we need to look at 9 and 9. So 1, 2, 3, 4, 5, 6, 7, 8. So we're looking at this. And then basically it has to be that because the data is already arranged in order. So I'll take 139 plus 142. And then I divide it by 2. Okay, punching that into the calculator, 139 plus 142 divided by 2. That gives me 135.5. Okay, but in cases whereby you're dealing with even data sets, for as long as you have just one number left, then that is it. That should be your median. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then the mod is basically the number that appears the most. Median is the middlemost number. Ne? So mod, the number that appears the most. So we have two 162s. Okay. And we also have two 129s. So we're going to say 129 and 162 because they are appearing the most number of times compared to all the other data sets. Then they want us to get the lower quartile and then the upper quartile. So I'll say Q1, then I have to look for Q3. Okay. So since our median is somewhere in between, okay, so then I need to look for the half of the first one. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4. So 129 is my lower quartile. Then 1, 2, 3, 4. 1, 2, 3, 4. So 152 becomes my upper quartile. Alternatively, you can look for the positions, né? Whereby you look at Q1 being a quarter of 18 plus 1. And then Q3 being 3/4 of 18 plus 1. That should give us more or less the same answer. All right, then the mean, which is the X bar, you must get the summation of all the items over the number of items, summation of X over the total number. So if I'm to punch this into the calculator, okay, so 147, okay, 131, 162, I have 142, 129, 110, 133, 165, 129 again, 152, 151, 139, 125, 130, 153. Oh, missed this one. So we said 130 and 153. Okay. So let me get the mean. Let me get the mean. So I'm getting a mean of 140.61. That's if I'm looking at just the mean straight away. Alternatively, if I had to find the total, it's going to be 2531 over 18, which should give me the 140.61 centimeters. Okay, so that is how this question would have been approached. Okay, so as you approach your examination, just know that you are in position to determine the median, the mode, at least the lower, the upper, or even drawing a box and whisker, okay, to represent the 5-number summary or question of this nature. Then question 2, that deals with group data, because the first one is just ungrouped. Then figures in the table below show the ages to the nearest number of 30 people that are negotiating a mortgage in a bank. The data is given as such. Then they want us to complete the frequency table in the diagram. Okay. So what we're going to do is we can just quickly do this and we tally it up and yeah, we go to go. So what I can see is that for intervals between 25 and 33, which means we're looking at 25 up to 32, okay? Between 25 and 32. That should be our point of interest. So 25 up to 32, I have 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the frequency is 10. So we represent that using tallies of that sort of format. Okay. Then 33 to 40. So between 33 to 40, just up to 40. So it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So the frequency is 13. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 2, 3. Then between 41 up to 48. Between 41 to 48. That should be our next target. So this is going to be a 1, 2, 2, we have 3, then we have 4. So 1, 2, 3, 4. And then whatever is left must be 49 to 57. Where is 49? So here we go, number 1, number 2, number 3. Okay, let's see if it adds up to 30. This is going to be 17, 20, and 30. Perfect. So which means our frequency table is done and dusted. All right. Then I use the information from the frequency table to draw a histogram. Okay. So what we know is that a histogram is just a graph with no spaces. Ne? So if I call this my 25, probably 33, and then a 41, then a 49, and then a 57. Then this side I can, is it gonna make sense? Yeah, I think it should. So it's 1, 2, 3, 4. So I can have frequencies of, let me have 2, 4, 6, 8, and maybe 10. Okay. So for the first one, which is a 10, the bar must be in that direction. Then we have a 13. Okay, so 12 and 14. 13 is somewhere halfway there. So you raise that up. Then we have a 4, which goes in that direction. And then a 3, which is somewhere there. So for as long as your bars are of equal shape and your bars are connected to each other, then we shall call that a histogram. So we should not only look at the histograms, but also familiarize yourselves with drawing the bar graphs or even line graphs. Yes. All right, then they want us to draw a frequency polygon on the special answer sheet. So a frequency polygon is one that can be obtained from a histogram, okay? So from this histogram that I came up with, let's see. So we can just get half or the middle class into in the middle of the bars, middle of the bars, and then middle of the bars. Then what happens is that we connect those points using a straight or using a ruler, okay? So that to that, then this to that, then connect this to that, and then connect this to the starting point of the class, which is this, then to the last point. So this becomes our frequency polygon, the green one. All right, so that is question number 2. Then question number 3, which is usually the analytical geometry, okay? This carries quite some substantial amount of marks, and we need to pay attention to how we approach this question as well. So question number 3, are telling us that the diagram below, we have A, which is -3 and 7. We have B, which is -8 and 2, and then C, which is 4 and 6. So vertices of the triangle ABC. Then AD is just drawn such that D is -2, and the K, which is the midpoint. So the keyword here is the midpoint of BC. Then 3.1, they want the gradient of BC. So I think I can write it here. So we know that gradient can be obtained by getting the change in Y over the change in X, okay? Which means if we have our Y2 minus Y1 over X2 minus X1. So since they're looking for gradient of BC, if I call this my X1, Y1, call that X2, then Y2, then we do the substitution. So it's gonna be 6 minus 2 over 4 minus 8. Simplifying that, I'll have 4 over 12, which becomes 1 over 3. So that becomes the gradient. Then 3.2, they want us to get the length of BC. So with the length, remember length is distance. So we need to apply the distance formula. So distance formula is given as x minus x1 squared plus y minus y1 squared. Or you can say x1 minus x2 squared and then y1 minus y2 squared. So if we do the substitution, it's going to be the square root over x, you can take 4, minus 8 squared. And then my y is going to be 6, but minus 2 squared. Then when I punch this into the calculator, it's going to be something like, that's a 12 squared plus, that is a 16, which becomes 12 comma something. So that is 12,65 units. Ne? But we can also give our answers in SAT form. All right. Okay, so if we are to use the SAT form, it should be the same as 4 square root of 10 units. Okay, but in most cases, we prefer it to be in the SAT format because it's easier to use. All right, then they want us to get the value of K. Now remember K, or the coordinate D, or the point D, is the midpoint. So you can use the midpoint formula. So this is 3.3. So midpoint is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So since we are just interested in K, can get the 6 plus the 2 divided by 2. Okay, so it's going to be 6 plus 2 divided by 2. That's 8 divided by 2, which gives us a 4. So if that is true, then we move on to 3.4. They want us to show that AD is perpendicular. Okay, so this symbol is perpendicular. Alternatively, they could have asked you to prove that the lines are parallel or something of the sort, okay? So if we are to prove that lines are perpendicular, we need to make sure that the gradient of AD multiplied by the gradient of BC must give us a -1. So we already have our coordinate of K, which is 4. So this is going to be 2 and 4. We have the gradient of BC, which we got as a third. So we expect the gradient of AD to be -3. Okay, let's work it out. So gradient of AD, we said y2 minus y1 over x2 minus x1. So whichever one you call x1 or x2, let me call this x2 and then y2. This should be x1 and y1. So that's going to be 7 minus 4 over negative 3 minus minus 2. So that becomes 3 over negative 1, which is negative 3. Then apply this formula and then tell us that negative 3 times 1 over 3 gives us negative 1. If that is true, then draw a conclusion and tell us, therefore, AD is perpendicular to BC. Now, if the question was asking about the parallel lines, remember parallel lines, we must get equal gradients. The gradients have to be equal if the lines are parallel. Okay, so let's keep that in mind. So for parallel lines, gradients are the same. Gradients are the same. And we could also use other figures or shapes. Let's say we give you a rhombus, a parallelogram, and then apply such properties, okay? So we just need to remember the properties of most of those 2D shapes as we work out our analytical geometry. All right, then question number 4. Question number 4. This should be marks for everyone, okay? Are telling us that if x is 66,4 and then y is 114,7, can we evaluate to decimals? So to evaluate is like to find the exact answer or the exact value. So in this case, we need to use our calculators and apply what we call the substitution. So where there is x, we shall replace the 66,4. Where there is y, we can put 114,7. So this is going to be the cos of 66,4 plus 114,7. Make sure your calculators are in degrees, that they are set in degrees. So this is going to be 66,4 plus 114,7. What is this giving us? It's giving me a very funny answer, which is -1. If I'm to round off just to 2 decimals. Okay, so it's -1,00, because -0,998 and so on. So that's what I get, because I know that 66,4 plus 114,7 gives me 181, something. All right, so that's what I'm getting. Then I move on. And then apply for the second one, 4.1.2, replace x with 66,4. So that's going to be 2 sine 66,4. Or you can break this down and tell us 2 times what the sine of 66,4 is. But I'll just prefer to write everything at once, 66,4. This gives me the 1,83. Okay. Then cosec. We know that cosec is the reciprocal of 1 over cos. Is that true? No. This is 1 over cos gives us a sec. Then 1 over sine gives us the cosec. So I'll say 1 over the sine of 66,4, which is going to be 1 over the sine of 66,4 is 0,9164 and so on and so forth, which means my final answer is going to be saying 66,4. Close that bracket. I'm getting 1,09. So this is the final answer that we want. So that's how we would have obtained those marks, okay? Then 4.2, they want us to determine the value. Okay, now we are solving trig equations. When you're solving such equations, just make sure all the numbers are on the other side and then the trig ratios are just isolated. Okay, so 4.2.1, I'm going to move this one that side so that the sine theta is on its own. So that's going to be 1 minus 0.38. So which means the sine theta is going to be equivalent to 0.62. Then for me to get the angle, I must press the shift and then the sine symbol so that I get the arc sine of 0.62. Arc sine of 0.62, which is 38, they want one decimal, which is going to be 3. All right. Then for 4.2.2, still do the isolation. So let's get rid of these 2. So over 2 over 2. So we have the cot of 2 theta is equal to 3 over 2. But we know that cot is the reciprocal of tan. So it's as good as having the tan of 2 theta. So we can say 1 over tan of 2 theta is equal to 3 over 2. Can switch this around so that the tan of 2 theta is going to be 2 over 3. Then what I'll have to do is find the arc tan, so which means 2 theta should be equal to the shift tan of 2 over 3. So which means the 2 theta is, say, shift tan 2 over 3. That gives me 33.69. Then I can divide both sides by 2 and then round off my answer to 1 decimal less. Okay. Divide that by 2, I'm getting 16.8 degrees. All right, then 4.2.3, divide both sides by 2 so that the cos is on its own. So cos of 3 theta minus 60 is going to be 1.71 divided by 2. We get to 0.855. Then let's find the arc cos, the shift cos of this, which means it says 3 theta minus 60 is equal to the shift cos of 0.855 is going to give me. So shift cos of that, I'm getting 31.24. Then I need to move the 60 that side, which will be an addition, which means 3 theta is going to be 91.26. And then I'll divide both sides by 3. Okay. So 91.26. We say 2623. Said shift cos of 0.855. It's 91.24, not 26. Okay. Then we're saying we're dividing it by 3, which gives us 30.4. So that becomes the answer for that, and that's how we would have obtained that. Then question number 5, which is also trig. We're being told that the sine, if we are given the sine of theta to be 4 over 5, but the tan theta is less than 0. So this less than 0 simply means that the tan is a negative, okay? If they told us that tan theta is greater than 0, which means the tan is a positive, okay? Determine with the aid of the diagram without the use of a calculator, all of this. So step number 1, when you have questions like this, is for you to remember your cast diagram. Okay, it is CAST, meaning that all trig ratios are positive, only sine is positive, tan is positive, and all of that. So initially, they're telling us that sine is 4 over 5, which means this ratio is positive. So we need a quadrant where the sine is positive, but the tan is negative. So we need to combine this and this. The other way they can bring this is they give you a domain value to say 0 is less than theta is less than maybe 180, something like this. Or 90, blah, blah, blah. So something of the sort. So we need to just combine the two and then see. So for the quadrant where sine is positive and the tan is negative is quadrant number 2. So then I have to draw my triangle in this quadrant. So from there, we can see that what we need to do. Okay, so after doing that, all we need to do is now replace or substitute. We know that from our SOHCAHTO, okay, we know that the sine is opposite over hypotenuse. So the whole of this is going to represent our theta. So our opposite is 4, our hypotenuse is a 5. Then we need to apply our theorem of Pythagoras for us to determine what is missing. So I'm going to say r squared is equal to x squared plus y squared. Then for me to get the x is going to be the square root of 5 squared minus 4 squared, which will give me a 3. Okay, so if we have a 3, but remember this 3 is positive and negative, no? Since the square root of any number must be a positive and negative. But since the 3 is on the left-hand side, I'll make it a negative. So you're going to get marks for one, identifying the correct quadrant, and for calculating the correct value of this negative 3. Then we can answer the question. So tan is opposite, no, tan is what? Opposite over adjacent. So it's this over that. So it's 4 over negative 3. So you get the last 2 marks for just getting that ratio correct. Then 5.1.2, they want us to get 2 cos squared minus 1. Okay, so this is going to be 2 multiplied by the cos, which is adjacent over hypotenuse, so it's negative 3 over 5 squared. Then we minus 1. When you simplify that, it's going to be 2 multiplied by 9 over 25 minus 1. We know that 9 times 2 is going to be 18 over 25. You subtract 1. So that should give us negative 7 over 25. That's what I'm getting, guys. Man. I don't know. For people that are doing it, tell us how you approach this question. Okay, so what I mean by without using a calculator, we don't want you to find the value of theta, okay? But after doing the substitutions like this, you can use a calculator to simplify your final answer. There's no problem there. All right, then 5.2, which is the special angles. Now remember, with the special angles, we have the one of 45, which is 4, 5, and then 4, 5, which is 1 and 1, and then square root of 2. Then we have the one of 60 and 30, which is 2, 2, 1, 1, and then square root of 3. So how you remember this is entirely your choice, né? But you just have to know how to apply and how the ratios work. So we know that the cos of 0 is a 1, okay? So I'll replace this with a 1. Plus, we know that the sine of 60 is root 3 over 2. So root 3 over 2, I need to square that. And then the sec of 45, remember sec is the reciprocal of cos. So we know that the cos of 45 is just 1 over square root of 2. And then when you talk about the sec, which means it's root 2 over 1. So I'm going to multiply this. Remember, this is the square root of 2. I'm multiplying it now with the square root of 2. Break that down, 1 plus, that's going to be 3 over 4 plus root 2 times root 2. That becomes a 2. So 1 and 2, that's going to give us a 3 plus 3 over 4. Do your algebra of the fractions. So that is 12 plus 3, which is 15 over 4. So that is what I'm getting as my final answer. All right, so any questions, you can put them under the comment section, and then we shall see. So that is what we are getting as the answer. Then 5.3, which is also the application of the 2D trig, elevation and depression. So in the diagram below, a person is standing at a point A, okay, which is 30 meters away from B. They told us that. Point A and B are at the same horizontal. The angle of elevation of the first one is 15. And then the angle of elevation of the second one is 21, okay. Then they want us to get the distance between the two windows. So this is a window, this is also a window. They want us to get this distance. So in grade 10, all we need to do is apply the trig ratios, okay? It's the application. So if I look at the distance CD, which means I need to find this entire distance, and then I also need to find this entire distance and then subtract the two distances. So in that, I'll look at the big triangle. So from BAD, the biggest triangle bed. So I have this as my adjacent, and then I'm looking at getting the opposite. So the trig ratio that combines adjacent and opposite is the tan. So I'll say the tan of 21 is equivalent to the opposite, which is BD over 30. Make that over 1, cross multiply. So BD times 1 is BD. We have the 30 times the tan of 21. All right. So 30 tan of 21, that gives us 11.52 meters. Then I'll do the same thing from that other triangle ABC and apply the same things as I'm looking for the opposite also. So I'll use the tan, but then it's going to be the tan of 15. It's going to be BC over the 30 cross multiplication. So BC is going to be 30, the tan of 15. Okay, 30 tan of 15 is giving me 8.04 meters. Then the distance CD is going to be distance BD minus the distance BC. So 11.52 minus 8.04. 8.04, what we end up with? We end up with a 3.48 meters. So that is how we would approach that. So this question can also be asked using different contexts. Let's solve a boat that is moving from one point to another, or a flag, or a tower, or whichever format it is. All you need to know is which ratio are we going to look at. Okay, so that is question number 5. Then question number 6, which is the trig graphs. Okay, so we have F, which is the sine graph. And then we have G of X, which is the cosine graph. All right, then they want us to get the value of A. So where is A? A is the coefficient of the trig graph. So this coefficient simply represents what we call the amplitude, the maximum displacement. So when I look at F, if this line, the x-axis is our rest position, we can see that the graph can only reach maximum of 1, can reach a minimum of -1. So which means A is a 1. What you're told is that for us to get the amplitude, you can get the maximum minus the minimum divided by 2. So our maximum is a 1 minus the minimum -1 over 2, which is a 1. Then 6.2, they want us to get the range of G. So when you talk about the range, you're basically looking for the Y values. So for Y values of G, we can see that G can go to +2 and then can also go up until 0. Okay, so 2 and 0. So we're going to say that 0 is less or equal to y less or equal to 2. Alternatively, y is an element. We use these brackets, 0 and 2. So these ones simply show that the graph or these points are inclusive. Then these curvy brackets simply indicate that the numbers that we indicate there are not part of the set of interest. Then they want the amplitude of G. G. Okay. So what's the amplitude of G, guys? So since our maximum is a 2 and the minimum is 0, so 2 minus 0 divided by 2, which means it's a 1. Amplitude is 1. But we can also take it from the graph itself, okay? Because they told us G of x is the cos of x plus 1. The number that is in front there, it's an invisible one, okay? So that becomes the amplitude. Then for which value or values of x will f of x be greater or equal to g of x? F of x be greater or equal to g of x. So for this, we need to look at the graph of f being above the graph of g. So where do we find f to be above? So you can see just this section. That's when f is above g. Other than that, it's below. So we're going to say 90, okay, is less or equal to x, less or equal to 180 degrees. All right, then for which values do we find g of x minus g of x minus f of x equal to 2? So in other words, if we look at the difference between the two graphs, okay, this and this, that and that, we must get a 2 for which value of values. Okay, so what are we going to do? G must be on top, then f down. So G is on top, f is down. The difference here is a 2. So in that case, the first answer will be x is a 0. Okay. Where else do we find the difference to be a 2? We can see here. If G is on top and f is down, this is a 1 and that is also 1. So at 270, x is 270. Okay. What about this other one? F is still down, G is above. So this is also a solution. X is 360. So those are the values where G is greater than F, but giving us 2 units. And then if F is reflected across the x-axis, write down the new equation of H. So when you reflect about the x-axis, it's like you're flipping it around, which means your graph is going to be in this sort of direction. And what changed will be basically the sign of the y. So which means that our h of x should be, what was f? It's 8. So it means it's going to be negative sine of x. Okay, so that is how to approach a trig function question. All right, then question number 7, which is the measurements. They're telling us that the roof of a canvas state is in shape of a right pyramid, having a perpendicular height of 0.8 meters on a square base. The length of one side is 3 meters, okay? Calculate the length of AH. So what we can see is that from this triangle of ours, let me just extrapolate it. Okay, so if this is 0.8, if this is 3, but we're looking at halfway, which should be a 1.5, what is that distance? Okay, so that distance, we can find it using the Pythagoras theorem. Okay, so r squared is x squared plus y squared. So that's going to be square root of 0.8 squared plus 1.5 squared. If it's a sad form, well and good. So that is square root of 0.8 squared plus 1.5 squared. Okay, so I'm getting 1,7. Okay. So that's 1,7 meters plane. That is 7.11. Then 7.12, calculate the surface area of the roof. Okay, so this is the roof now. So since it is a square-shaped pyramid, which means that this surface is going to be the same as that and so on and so forth. So since I got this, my height as 1,7, my base is going to be 3, which means the area of one face, of just one face of the roof, is going to be a half times the base times the height. That's a half. Our base is 3. Our height is 1,7. But how many faces are we looking at? 1, 2, 3. There are 4. That's fine. Because one face is this, and then we're looking at 4 faces. So let me just combine everything once and get over it. So 3 times that. So I'm getting 10,2 meters squared. So that is the surface area of the roof. Then if the height of the walls are basically 2,1, okay, so this is a 2, calculate the total amount of canvas required to cover the tent if the floor is excluded. So what this question is asking for is the surface area of this entire thing. Okay, so which means the sides are going to be covered as well as the roof. So the area of this face, okay, we can say that area of one face is going to be 2,1 multiplied by 3, which is 6,3 meters squared. But since we're talking of 4 faces, it's going to be 6,3 multiplied by 4. Okay, 6,3 times 4, I'm getting 25,2. And then we must plus the 10,2. So that should give us a 35,4 meters squared. This is how much cloth or how much canvas will be required to cover the roof as well as the sides. Then 7.2, there's a metal ball that has a radius of 8 millimeters. Okay, so if it is 8 millimeters, they're telling us that the volume of a sphere is given as that. Calculate the volume of the metal used to make this ball. Give your answer to 2 decimals. All right. So volume is how much space an object takes up. Okay. So we can determine the volume of the metal. Okay. They want the answer to decimals. They're not specific which units to use. Okay. So we're going to say 4/3 pi multiplied by the radius, which is 8. So using your calculator, we are saying we are multiplying this by pi and then multiplying it by 8 cubed. Okay, 8 cubed. That is giving me 2144,66 millimeters cubed. So 2144,66 millimeters cubed. Then if the radius is doubled, can we write down the ratio of the new volume? So what usually happens that when you double the radius, the volume must increase in the ratio of 1:8. So new volume to the original must be 8:1. Okay, let's just show people how that is done. So if I look at 4/3 pi radius squared, if this is my original, and then 4/3 pi, this is now 2r, but cubed. So if this is my original, this is my new, I'll keep the original, it's a cubed. This is 4/3 pi. That's going to be r cubed, but then 2 cubed gives me 8. This cancels that. I'll have 1:8. So that's why I'm saying it's 8:1. Okay, so you'd like this bowl to be silver plated with a thickness of 1 millimeter. What is the volume of silver required? What is the volume of silver that is required? So for me to get the volume of silver that is required, it's as good as me increasing the radius of the sphere by just 1 millimeter. So which means the new radius is going to be 9 millimeters. Okay. So let me get the volume with 9 millimeters, and then I'll subtract the 2. That will give me the volume of the silver required. So it's going to be 4/3 multiplied by pi multiplied by 9 cubed. And then I'm subtracting the original that we had as 2144,66. All right, so 4/3 multiplied by pi, we're saying multiplied by 9 cubed. That gives us 3053,63. 2144,66. All right, so when you subtract that, I'm getting something funny, which is 908. Okay, 908,97. This is millimeters cubed. So that's the volume of the silver that must be used. All right, then question number 8, which is the Euclidean geometry. This is one topic that really carries quite a lot of marks if you're to compare it with all the other topics. Okay, so try as much as you can to get as much marks as possible. So this question is telling us that in a parallelogram, okay, so in Britain, our main focus is going to be these 2D shapes, and mostly the parallelograms, okay? So in the parallelogram below, PW bisects QPS. In other words, this angle is the same as this angle. Then SW bisects PSY, so which means this is the same as that. Then PW is parallel to ST, and then PT is parallel to WS. Then 8.1, they want us to prove that X plus Y is 19. We need to prove that X plus Y is 90. So PQRS is a parallelogram, which means that these sides are also parallel. Okay, the opposite sides of parallelogram must be parallel. Okay, so having seen that, since they told us that these angles are equal and all of that, all I can say is that P2 is going to be X. Okay, that's my first statement. And then S2 is also going to be Y. Reason is saying that PW bisects QPS. And then we're saying that SW bisects PSR. So remember, for every statement that we give in this case, it's always paramount that we also give reasons, okay? So if that is true, which means that is X, and then this is also Y. So we're gonna add the whole of P plus the whole of this S inside here, and then equate them to 180 because they are co-interior. Okay, so before I do that, I can still say that PQ is gonna be parallel to SR. The reason those are opposite sides of a palm, or we call it a parallelogram, which means I'm gonna have 2X plus 2Y should give me 180 degrees, okay? And the reason, those are co-interior angles because PQ is parallel to SR. Then you can divide through by 2. You have X plus Y should give us just 90 degrees. Okay, so we're done proving that. Then 8.2. They want us to prove that PWST is a rectangle. Can we prove that PWST is a rectangle? So what we know about a rectangle is that the opposite sides, okay, have to be parallel, which we've already been told. Then if that is true, we can also look at the angles of interest and see whether we can have the same angles and all of that. So if that is X and X, remember X plus Y must give us a 90. So what I'm going to do, I'm going to start by saying that PT is parallel to WS. We've been told, or we can say it's given. And then we know that PW is parallel to TS. That is also given. So all we need to do is just prove that there is a 90 degree because that is the only property of rectangles that distinguishes them from a parallelogram or other points. So we're going to say that this Y is the same as this angle. So TPS is equal to Y. The reason, those are alternate angles because TP is parallel to SW, okay? And then I can also prove that this is an X. And if that is true, I'm going to say that TSP is X. The reason, we're also going to say alternate angles because TS is parallel to PW. And if that is true, remember we said X plus Y is a 90. So T is going to be a 90. So since T is a 90, remember we said X plus Y must give us a 90 from the previous question. So a 90 plus a 90 must give us 180 to give us the total angle or the angle sum of this particular triangle. So for as long as we have a 90 somewhere, definitely we know this is also going to be, all of this is going to be a 90 because the lines are automatically parallel. So for as long as we prove just 190, then draw the conclusion that PWST is a rectangle. You tell us the 90 degrees or the opposite sides being parallel. All right, then question number 9. ABCD is a parallelogram with AD being parallel to BC and then BA is parallel to that. They want us to use the diagram above and prove the theorem that states that the opposite sides of a parallelogram are basically equal. So in cases like this, there will be no need for construction since it's already been done for you. What we need to do is prove that this triangle and this one, they are congruent. Okay. We need to prove that the triangles are congruent since we need to prove that the opposite sides are equal. So what we can say, what we can do is let's use the angles since they want us to prove the sides. Let's use the angles. So we can start by saying that this is the same as that. So B2 is the same as D1. That is alternate angles because AD is parallel to BC. If that is true, which means this angle D2 is the same as B1. So B1 is the same as D2, still the same reason, alternate angles, because AB is parallel to CD. If that is true, which means the angle A must be the same as angle C. That will be the remaining angles of a triangle or angles in a triangle. So meaning that ABD is congruent, okay, to BCD. And the reason that we're using is that we're looking at the angle, but we can also look at BD being common. Okay, that can also be an alternative. So that we look at side angle and angle. So if that is true and you've done the proof of the congruency, then you can go ahead and say, therefore, our AB must be equal to CD, and then the AD should be equivalent to BC. So you've proved that the opposite sides are technically equal. So we use congruence in most cases. All right, so that is question number 9. Then question number 10, which is the last one. Question number 10. Okay, so we're saying in the diagram below, D and E are midpoints of the sides A, B, and BC of that triangle. Point P is on BC such that PA is equal to PB. We're saying PA. Okay, so PA is the same as PB. And then PB cuts at that point. Okay. So since they told us that these are midpoints, from our midpoint theorem, okay, automatically we know that these lines are going to be parallel. So let's start by stating that D is parallel to AC, and that is going to be the midpoint theorem. So if that is correct with the midpoint theorem, and we know that this is the same as that, it's equal to that. It simply means that B1 is the same as A. Those are angles that are opposite, equal sides. Angles that are opposite, equal sides. So which means this angle is the same as this angle here. But now since the lines are parallel, which means that this angle A is the same as B2. So it's saying A is the same as B2 because those are corresponding angles. Because initially we say that AC is parallel to DE. Okay, so if that is true, then we've proved that B1 and the B2 are the same. Remember, for us to prove that a triangle is isosceles, either the sides have to be equal to each other or the angles have to be equal. So in this case, we're going to draw a conclusion and say that RDB is isosceles, and the reason is going to be two equal angles, or we're going to say that let's just say two equal angles, or angles that are opposite, equal sides, or sides that are opposite, equal angles. All right, so that is how this paper would have been approached, and just expect just more or less the same concepts under Euclidean, or proving about that a shape is a parallelogram, proving certain aspects, integrating the aspects of Euclidean and the angle relations. Also remember some bit of measurements. If they don't give you a sphere, they could give you a cone or even a cylinder, whichever format, but just make sure that even the units are the same, okay? Remember how to calculate the areas, the trig functions, okay? It could be a tan, could be a sine or a cos or a combination. So whichever one it is, yeah? The application of the trig rules or the trig, and then the trig itself, and the spatial angles and the cast diagram, and how to solve the trig equations. Remember how to do the isolation first, and then before you find the shift sine, shift cos, and the shift tan. And then the substitution also, please, do not leave out these marks. You just substitute, use your calculator in this case, and get the answer. The parallel and perpendicular, keep that in mind under the analytical, how to calculate the gradient, how to calculate the distance, and how to determine the midpoint. That is also key and important. Then group data is also a must. So sometimes from this group data, they can even ask you for the estimated mean. Okay, just remember how to calculate at least this, whereby you get a f and the x. In other words, the midpoint multiplied by the frequency, and then you divide by the summation of the frequency, the total frequency. So remember that under the group, sometimes they bring it as well. Then you remember what we talked about initially, that for the ungrouped data, same only if it's possible, median, mode, mean, the quartiles, the box and whisker, all of that. So I'll stop at that and just wish you guys the best. Let's meet when we're looking at some memorandums for some groups of papers that would have been written on that particular day, and all the best. Bye-bye.